Welcome to our student. I am Professor S.S. Iyer. Today we discuss in finite element analysis the very important topics like planar assumptions. In planar assumptions, first we discuss about properties of stiffness matrix. The properties of stiffness matrix is it is a symmetric matrix. The number of rows or number of columns in stiffness matrix is equal to number of degree of freedom of element. The summation of any row or any column is equal to 0 for a stiffness matrix. The main diagonal elements are always positive. If boundary condition is not specified, then stiffness matrix becomes singular. Stiffness matrix is banded matrix for isoparametric elements. So in planar assumptions, it is very important topics. In there, all real world structures are three-dimensional. It is very important sentence like all real world structures are three-dimensional. For planar to be valid, both the geometry and the loads must be constant across the thickness. This is the diagram of x, y, z axis. Now we discuss about plane stress. There is equation sigma x, sigma y, sigma z along. All stresses act on the plane, normally the xy plane. Due to Poisson effect, there will be strain in the z direction, but we assume that there is no stress in the z direction. Sigma x tx t yz will be 0. In plane strain, all strains act on the one plane, normally the xy plane, and hence there is no strain in the z direction. A thin planar structure with constant thickness and loading within the plane of the structure like xy plane. This is the xy, this is the zy plane. A long structure with uniform cross section and transverse loading along its length, z direction. So this is the equation of stiffness. Axial stiffness is equal to capital E into A upon L. Bending stiffness is equal to EI upon L cube. Torsional stiffness equal to G into J upon L. This is the equation. This is the axial stiffness greater than bending stiffness. This is a very important topic like types of analysis. There are three types of analysis like one-dimensional analysis, two-dimensional analysis, three-dimensional analysis. In one-dimensional analysis, there is also one subtype like uniaxial loading, plane loading, multi-axial loading. Axial loaded bar element, this is a tension compression only. FE model, nodal displacement. In transverse loading beam, this is the FE model. Why I section is better, this is the nodal displacement. This is a very important topic. In beam element, this is the torsion. This is the how hollow shaft is better than solid shaft. This is the shear stress. This is the torsion of non-circular shaft. This is the torsion of non-circular shaft. This is the very important diagram. This is the plane element in plane loading. This is the all loading conditions are given. Also there is very important topic like penalty approach. It is an alternate approach to achieve the solution. As per this approach, the rigid support is considered as a spring having infinite stiffness. The support is modeled with very high stiffness. To represent a rigid support, the value of stiffness must be infinity, but an infinite value will create problem in further calculations. These are the very important topics. This is the shell element of plate bending. This is the membrane forces. This is the membrane forces plus bending moment. This is the example car body and tank containers. This is the quadratic element versus triangular element. Triangular element is steeper than quad, results in lesser stress and displacement if used in critical location. Quadratic element is more accurate than triangular element due to better. In symmetric boundary conditions, a structure possesses symmetry when its components are arranged in a periodic or reflective manner. The different types of summary may be reflective, rotational axis symmetric, and translation. In essential boundary conditions, the type of constraint may be displacements. In symmetry conditions are used to improve symmetry or anti-symmetry resistance at certain points or lines of structural symmetry. The examples of symmetric boundary conditions as shown in figure. So today we discuss about all these basic things. So thanks all of you.